Okay, so Ryan, we're going to talk about these rational functions because you started them yesterday. I know you did, so you've got something on here. Let me get mine large so you can see it a little bit better. Oh yeah, totally recording. Things that you want to think about for rational graphs is that you want to identify those asymptotes because when you put it in the calculator, or if you have my graph, even then, those graphs are pretty deceitful. They don't give you everything that you want. So you have to remember the big things that we look for are the asymptotes, or the behavior pieces. So like horizontal asymptote, Grant, is wherever you guys are always looking at these coefficients, these degrees, top and bottom. When it's bottom heavy, it is always a horizontal asymptote of y equals 0. So if you think of, it's all about, if you put really big numbers of x in there, can you tell it gets really small? Because the denominator gets big, Ryan and Ethan. It does, it gets huge. And a really big denominator means it's a kind of a small number. So as we get huge numbers of x, it goes towards 0. And if you look at my graph, you can totally see it. That graph definitely wanders towards 0 as x gets really big. That's a big deal, especially with like range and things like that that we have to get to. So when I also want to know about vertical asymptotes. And vertical asymptotes are where there's vertical lines that break the graph up. We get that from doing your set the denominator equal to 0. So, and we factor it usually. And things like, I don't know, x squared plus x minus 12 is kind of handy dandy. It's like x minus 4, x plus 3, or x plus 4. X minus 3, maybe. Good factors. And then you can say, oh, I got it. I got vertical asymptotes x equals negative 4 and x equals 3. And I think we even mentioned this yesterday. So that's our first assumption. That's what we usually write. We get all excited. And then you look at the graph, and there's only a vertical asymptote at negative 4. So what's up with x equals 3? I don't see a vertical asymptote. It's all because it's top and bottom. If you write a ratio, if you have the factored form of this and one of those factors cancels instead of a vertical asymptote, you have a hole at that location. So x minus 3 canceled, so to speak. And so that means there's a hole instead of a vertical asymptote. So what I do is just relabel that. Instead of x equals 3 as a vertical asymptote, I'll say there's a hole at x equals 3. And you can see the graph does not indicate a vertical asymptote at 3. So the graph helps me decide, oh yeah, there's something else going on there. There's a hole. And it doesn't show up. You just have to draw it. A little exaggerated circle of some kind. Done. So domain-wise, then your domain just breaks up around those. So it's any x except for the two, negative 4 and 3 that we just ran into. Even though one of them's a hole, that counts. That's a discontinuity. So negative infinity to the first one, which was negative 4. Negative 4 to the next bump in the road. And then 3 to infinity. All that stuff goes in there. Range-wise, you know there's a horizontal asymptote at 0, and that's where there's a break there. Now, super technically speaking, there would be another break wherever that hole is in our range too, because you're going up. Isn't there like a gap there? Right there, there's also a gap in there. So if we want to be super technical about this, and we could, it'd be nice to know what that little gap is at 3 on our graph. And if you wanted to know what it was, you'd actually have to put 3 in, and I'll use a pretty color like blue. Put it in there. If I put 3 in for x to see what I get out, that'd be 0 over whatever. So we'd end up with, I don't think would it really be 0? Does that make sense? That's a crazy process. Like, it actually ends up being 0 over 0, because remember, this is actually your denominator here. You'd be putting 3 in this, and you get 0 over 0. You'd be dividing by 0. It's illegal. 3 is one of our illegal values, and so it's actually kind of hard to tell what that height is. We'd actually have to use some of our limit knowledge, or we'd have to go really, really close with our calculator and figure it out. So for our purposes, I'm going to let that slide for right now, but know that there is a break there. And if you see it, good for you. We're just kind of ignoring it for now because we'll have opportunity later to let Charlie figure it out for us.
Do we need that for the final?
No.
I don't even have the sheet.
It's up here on the table.
I never got one.
Come on up and get one up here. So, x-intercepts set y equal to 0. Oh, silliness. So, setting y equal to 0 means the whole thing equal to 0. So, that means the x minus 3 over, let's use the expanded form, x minus 3. We set that whole thing equal to 0. And in fact, I'm going to go a step further. When you set it all equal to 0, it will actually come in handy to go, remember these canceled? We can actually use that at this point. We know there's a hole in our graph, so there's no reason to graph the whole thing. We can actually think of it as 1 over x plus 4, which is like 1 over x shifted. This is a transition to the left 4. And if you look at our graph, that's exactly what we're seeing. It's 1 over x to the left 4. But we're setting that equal to 0. And if you remember with rational functions, it's equal to 0 if and only if the numerator is 0. And that's not going to happen. What that means is since I can't make it 0, there are no x-intercepts. And if you look at the graph, that's no surprise either. You don't see any x-intercepts. The graph just doesn't hit the x-axis. It does not crash into the x-axis. Isn't that crazy? I'm going to pull back for a minute there. Do you see all these big ideas and those rational functions are loaded? Kind of like Mr. Seeley. I just bought all this stuff from Amazon. All these snacks and things. You open up the box and it just tumbled out all these wonderful things. I just love Amazon Pantry.
Did it get stolen this time?
It was like a treasure box. What's that?
So they didn't get stolen.
This time, no. And then we had everything came at once. We had costumes, PJ Masks costumes for the boys. They've got matching kind of costumes, alternate costumes. And then
He was interested in math books, but not food.
yeah, that's a goofy one. Yeah, they didn't take anything interesting. We'll find. I told you we've converted somebody to crazy math magic. Set x equal to 0. So if you put a 0 in for all those x's, if you want, use the simplified version. That means 1 over 0 plus 4. If I set x equal to 0, and that's just 1/4. There you go. So apparently, at y equals 1/4, we have a y-intercept, because when I put 0 in for x, that's what it says. Go to the graph and confirm. Does y equals 1/4 seem like a crossing point?
Yes.
Sure does, right about there.
Sure did.
Yepper. Now, shall we move to the next one? I think we should.
Wait, why did you use x minus 3
In the equation, did I use x minus 3? I cannot get my two-finger thing to work. Okay. Tell me more. You said, why did I not use x minus 3? In the intercepts, I think what you're asking, if I'm not mistaken, is why did I not use the original?
Yeah.
I use the simplified, the canceled form. So what I did is I canceled those x minus 3's, and what was left was this beauty, 1 over x plus 4. And it helped me find those values more simply. It was just nice. I just know there's a hole at 3. So it really is the graph of 1 over x plus 4. There's just a hole at 3. That's the part that I have to remember. But I like the values of it. You can actually use the original just fine if you want to. They're equivalent, except for the hole. 3. Yeah, the x minus 3 is canceled. All right, to the next one, if that's all right. You can ask again on those. I'm going to look for the same stuff. I want to know horizontal asymptotes. I want to know vertical asymptotes. The horizontal asymptotes are if you see the coefficients are the same, and the degrees are the degrees are the same, and then you look at the lead coefficients in this case. Or think of really, really, really big values of x. If I go to really big values of x, then I totally ignore the 2 and the 6. And I basically get like 1 billion over 2 billion, which is a half. So that's what we're looking at, what we're considering anyway. So the horizontal asymptote is a half. Y equals a half. And the vertical asymptote is whatever makes my denominator equal to 0. And what would make that 0? Looks like if I set it equal to 0, I get negative 6 over 2, which is negatory 3. That's the value it can't be, so I'm thinking of my vertical asymptote as x equals negative 3. I will look at that graph and I will confirm it, because I don't want to be crazy. And it sure looks like it makes sense. Okay. All right, so now, with all that information in there, get my thing to squeeze, there we go. The domain is all up to that negative 3, and then it skips it because of that vertical asymptote. I'm actually looking at the graph. And then it back down after negative 3 on to infinity. The range goes up, 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 up until it hits the horizontal asymptote. There's a gap at that asymptote. And if I look at my horizontal asymptote, there's a gap there, and it's at a half, not 0. So you've got to be careful. Negative infinity to a half, and then it comes back down after a half to infinity. X-intercepts y equal to 0. Or if I set the whole thing equal to 0, I cannot get it to work. There we go. Ding. Zillow digs. I'm going to set the numerator x plus 2 equal to 0. There's my original. Just having some my tablet issues. It's not responding very well. I'm getting. Okay. And remember, you can do x plus 2 over 2x plus 6, set the whole thing equal to 0, but I only really care about the numerator.
Why?
Because that is the only way you get 0. It's a great question. You can never, 0 divided by anything is 0. So just that knowledge helps me focus my attention. I only really need to see that that numerator is 0, and that means the whole function is 0. As long as it isn't a hole in my graph. Like as long as it's not a hole in my graph at that spot. That's what happened last time. When we set this equal to 0, and we looked at the original, and it looked like 3 would have been a place, but 3 was one of our values we can't put in. It's one of the things it was an undefined value. There's a hole in the graph there in that last one. Here, x plus 2, set it equal to 0. Negative 2, if you plug it into this graph, you're going to get out 0, and it works perfectly. Yeah, you can always just look at the numerator. X equal to 0, put it into both of those, you get 2/6, or y equals 1/3. And if you look at the graph, I definitely see negative 2 crossing, bingo, and I definitely see it crossing at 1/3 for the y-intercept. And just make sure you see it before you believe it. Make sure they match. All right, I think, how much time do I have left on my timer? Oh, it's supposed to be going off. I think I'm almost out of time. So we're going to break. Let you guys tackle what you haven't tackled on those two, and I'll start the second video in 2 shakes. Okay?